Hello everyone and welcome to the channel. In this video we will solve questions which were asked in previous few years on group theory, especially on this point group and symmetry operations. So I will be taking few questions from previous exams and we will try to solve them and try to explain them. Okay, so before solving these questions, I will be telling you few things which will be very helpful for you in like multiplication of two symmetry operations. So in that these things will be helpful for you. So first we will study that and then we will come back to the questions and we will solve them. Okay, so this method is called this matrix method of solving symmetry operations. What is this method? Like a few questions which were asked earlier in CSIR exam in June 2015 and before that. Mostly they were like for 2 marks question and once for 4 marks question they have asked about like if two operations are multiplied, then what you will get. This thing will be helpful for you in finding the multiplication table also. Okay, I will not be solving the I will not be telling you in detail about multiplication table because that is like the question from multiplication table are not asked in CSIR exam, and that is not that important from CSIR exam point of view. But yes, if you are in your masters and if you are dealing with those multiplication table and solving them, the questions from there it can be asked in your final examination of MSc exam. Okay, but for CSR point of view, multiplication table will not be asked directly, but yes, they can ask you about the product of two operations and all those things. Okay, so that I will be going to tell you. For that you have to understand few things about the matrix and multiplication of two matrix. Okay, so let's start that. Okay, so in this matrix method what we will do, we have three axes, x axis, y axis and z axis. And as I have told you that for our convenience we take these axes like this, that x axis is this one, z axis is this one and y axis is this one. Okay, so these are the three axes, and when we will perform certain operation on these axes, what will happen to the sign of these axes? Okay, what will be the transition in the size? So that we will understand from the matrix method. Okay, I will try to explain you using this axis system also, and like a few things you have to memorize also. So if the first symmetry operation, if you remember, that was the identity. So if you apply an identity to these three axes, okay, I'm writing that operation over here, identity operation. So what will happen to these three axes? See, identity operation I have already told you that in identity operation there will nothing will happen to these axes. Okay, and to the molecule also, if you are applying identity operation, then nothing will happen, the molecule will remain as it is. So these axes will also remain as it is, and the final resulting axis will be x, y and z only. Okay, so it will be like this. So this is the transition of in the axis if you apply identity matrix. If you are not familiar with symmetry operations and how to apply them, then I will suggest you go and watch my previous video which was on symmetry operation. Okay, so if you will watch that video, this video will be quite helpful for you from there. Okay, because I will be telling only the like I will not be going in that deep because I have already explained in that video. That video is quite long and that is very helpful. Okay, so go and watch that first and then come and watch it. So this one is for the identity operation. Now let's do the next operation, that will be x, y and z. And if we do a C2 operation along x-axis, okay, so what this operation tells, this tell that we are doing C2 operation along x-axis. So what we are basically doing, this is the x-axis. Along x-axis means we are fixing this x-axis and rotating other axis by C2. Okay, C2 is what? C2 is the rotation of 180 degree, means we are rotating this axis by 180 degree. So what will happen if you rotate a axis by 180 degree? Like for example, if I rotate this x-axis by 180 degree clockwise or anti-clockwise, what will happen? This axis will come this side, and you know that this will be the positive x-axis and this will be the negative x-axis. Similarly, Here we are fixing x-axis because this rotation is along x-axis, so we have fixed x-axis and we are rotating other two axes. So y-axis will rotate and by 180 degree, and it will become like this. Okay, it will go there, and z-axis will come downside, so it will be minus z-axis and it will minus y-axis. So x-axis will not change because that was fixed, only y and z will change. So what you will get x minus y and minus z. So this will be the resultant if you rotate this axis by like you do C2 operation along x-axis. Okay, similarly if you do along y-axis, then what will happen? Y will remain positive, other two will become negative. If you do along z-axis, then z will remain positive, other two will become negative. So this is the, like, the sign of other two will change. The axis along which you are rotating by C2, that will not change, other axis will change their sign. Okay, so this is C2 axis along x direction. Okay, now the next one will be plane. Okay, so x, y, z. If I apply a plane xy, so sigma xy I am applying, so what will happen? So I will draw again, so that this is x, z, y. X, z and y. Okay, so what will happen if I apply sigma xy? So this is sigma xy plane, this is the plane. Okay, so this is the plane. What will happen if I apply this plane? This plane will apply in, like, in all the direction, positive, negative, all the directions. So what will happen? This plane will reflect this plane, this axis, in opposite direction, like this. Okay, so what will happen? This positive z axis will change into negative z axis, and x and y axis are on the plane, they will not change. Okay, so in case of plane, if it is a xy plane, then you don't have to change the xy axis. The direction of the sign of the third axis will change. So x and y will remain as it is, and z will change to be negative z. Okay, so this will be the symmetry operation, means resulting axis if you apply sigma xy. If you apply sigma yz, then yz the sign of y and z will not change, sign of x will change. Similarly, if you apply sigma x z, then the sign of x and z will not change, x only y will change. Okay, so in this way you can do. So these were the few operations. Now let's check out one more operation is there, x, y and z. Okay, and if I apply inverse, okay, so if I apply inverse, then what will happen? All the axis will change. Okay, how? I've already told you that inverse is like it's along a center of symmetry. So x, y, x, z and y. What will happen? This will act as the center of symmetry. This will reflect x this side, y this side, and z this side. So all will change. Okay, so in this way, all the axis will change in inverse symmetry operation. So these were the few symmetry operations, and few things more I will tell you. These were the basic. Okay, these things were very simple to understand. Now few things which you have to remember. Okay, so till now we have studied about the transformation in the axis when there will be identity c2x, and that was only for c2 rotation. Okay, but and then we have studied about the plane and then about the inversion. But if the rotation is not c2, means if the rotation is not by 180 degree, it is by some arbitrary angle, say 120 degree or say by 90 degree, then this formula will apply. Okay, this matrix representation will be applied. For c and rotation, we have x2, y2 and z2. These three are the new axis which will be formed. Okay, means the axis which I was showing in the right hand side, these were x2, y2 and z2. Okay, but here I haven't, like, for the sake of like, so that you don't get confused, that's why I have just given you the direct form. But here it is very important that you should know that x2, y2 and z2, these are the new axes which will be formed, and this you have to remember that will be cos theta. I am not giving the full derivation, there is a whole derivation over here and lots of mathematics is here. I am not giving all those things. It's better to like remember simple things. You don't have to like go for the like whole derivation. Okay, so this thing, see, this thing is not only important here in multiplication of two operations, it is very important when you will be solving a character table. Okay, so for the, like character table solving also this is very important, so that's why I'm telling you to pay attention over here. So these x2, y2 and z2 will be the new axis which will be formed, and these cos theta, sin theta, theta will be the angle by which the rotation will be there. Say if we have c3 rotation, c3 means the angle will be 120 degrees, so the theta will become to be 120 degree. Okay, so for proper rotation it will be cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. This will be a 3 by 3 matrix. Okay, multiplied by the previous axis x1, y1 and z1. Okay, so for like we are taking them x, y and z, so you can take them x, y and z also. No need to take x1, y1 z1. Okay, so these will be x, y and z only. Again, for improper rotation the new axis formed will be x2, y2, z2, and that will be multiplied with cos theta minus sin theta 0, sin theta cos theta 0 0 0 minus 1, and x1, y1 and z1. So here you have to perform what do you call multiplication of matrices. So multiplication of two matrices is very important to know. If you are a bio student, then it will be quite like, so it will be little bit difficult for you to understand, but I will make you very I will make it very easier for you to understand. Okay, and if you are a mathematics student, then I'm sure that you must have studied these things in your class 12th or in your graduation, so this will not be a difficult job for you. Okay, so this is a 3 by 3 matrix and it will be multiplied by simple means a 3 by 1 matrix. So this matrix can be multiplied and I will tell you how. Okay, so I will tell you this or when we will solve the questions. Okay, so for now you just have to remember for C and rotation we have, and you have to be very careful about the sine and this. See, cos theta sin theta 0, sin theta cos theta 0 0 0 1. In proper rotation we have minus sign just here. Okay, for improper rotation we have same thing, cos theta sin theta 0, sin theta cos theta 0 0 0 1, but we have minus sign. Earlier it was here only, now the minus sign has shifted to the other sin theta and this one has become negative over here. So these things you have to keep in mind, and this you have to write somewhere. Okay, so that you never forget this. And all this transition which I have told you till now, they all have derived from this thing only. Okay, so is this one, it has been derived from here only. So okay, so now let's solve few questions. Some of them will not be on this, so first we will solve those questions which are not on all these things. Later on we will go to the like questions which are on these symmetry multiplication of two operations. Okay, so let's solve them. Okay, so the first question, the question it was came in CSIR June 2016 exam for 2 marks. Okay, see, I'm not taking those questions which are asked from the character table. That I will solve when I will like publish a video on character table. Okay, so till now I have given videos on the symmetry operations and point group. That's why I'm solving questions from there only, so that you are able to understand from watching my videos and then solving questions. Okay, so I'm doing those questions only from the paper. Okay, so okay, so the question says that the symmetry point group of the most stable geometry of the following molecule. The molecule is given over here, and this is alene type molecule, and they have asked you that what will be the symmetry point group. So first we will draw this molecule. Okay, see, so if you draw this molecule, this is like alene type molecule in which this hydrogen and this chlorine, they are on the plane, and this hydrogen and this chlorine, they are like they are on the like this is on perpendicular upward of the plane, and this chlorine is perpendicular downward of the plane. Okay, it is above the plane and it is below the plane. Okay, so this is the structure of the molecule. And if you have watched my previous video, I have solved this question over there in the example section, but here also I will be going to solve this. So for the sake of understanding, I am not able to draw it properly, but I have tried to draw this molecule in and this cuboid. Okay, you can also try to draw this molecule to find out whether any plane is there or not. So first of all, we will check the axis. So is there any axis? So if I like see, they have said that for most stable geometry of the molecule, okay, the geometry should be most stable one. So if I rotate this molecule like from here, from this carbon, if I rotate this molecule by 180 degree, if I rotate along this plane, okay, see, we have this face, this face in which hydrogen is in one diagonal and only one vertex, and other hydrogen is on the other vertex. One face is back side, okay, this is the back face of the cuboid, where one chlorine is here and other chlorine is here. So if I pass axis like this from this plane, from this face, and it goes to the other face, and if I rotate the from that axis by 180 degree, what will happen? This hydrogen, this will come here and this hydrogen will move that side, okay. Similarly, simultaneously, what will happen? This chlorine will go there and this chlorine will move this side. So it is not possible to like find out from this structure of the molecule, but from there here it is quite clear that there is a plane, sorry, there is an axis along the face, along this front face and passing through the back face. If you rotate this molecule by 180 degree, the hydrogen will shift themselves and this chlorine will shift themselves. So the axis, one axis is there that will be, that is rotated along 180 degrees, so the axis is C2 axis. Now let's check out if there is any plane, okay. So is there any plane over here? So if you will try to find out a plane, like a plane along this face, so it is not possible, okay. Okay, so but if you are thinking about a plane which will be passing diagonally along this face, okay, cutting these two hydrogens and reflecting these two carbon, chlorine, then that plane is not possible, because if you will pass this plane like this alene carbon, all three carbon, that will not be sliced properly, okay, means they will not be reflected properly. See, if you have a straight line and if you put a mirror like this, then like a slant mirror, then you will not get the reflected image straight, okay, the reflected image will be slightly slant. So the like it is the basic thing that like this, if it would be a single atom between, okay, not these three carbons, then the plane will be possible, okay, but here these three carbons are there, this is alene system, so there will be no plane, okay. So plane is not possible here, only just axis, so there is only a C2 axis, so the point group here will become C2, so the correct answer here will be C2, okay. Similarly, we will go to the other question, that the pair of symmetry of groups that is associated with only polar molecule is. So this question, like if you have watched my previous video, you would have done this question very easily. What it has said that a polar molecule, what is the basic need of a polar molecule? That both the two atoms should not be same, okay, or there should be a dipole moment. So if we have a H2 atom, okay, H2 molecule, H atoms are there, that will be non-polar. If we have HCl, means both atoms are different, then that will be a polar molecule. So the basic need of a polar molecule is both the atoms should be different. That means the molecule should be asymmetrical. And I have told you that in asymmetrical molecule, for a symmetrical molecule, we have d infinite H. Okay, for symmetrical. This I have already told you in my previous videos. And if we have a asymmetrical molecule, then we have C infinite V. Okay. So C infinite V will be in asymmetrical molecule. So asymmetrical means the molecules are polar also. So if you know this thing, your answer becomes very easy for you. Only fourth option there is C infinite V, so the correct option will be fourth option. You can like check out all the different point groups and you can check that whether any of the like polar molecule is giving both of the pairs in any one, okay. You can take examples. I have given all the examples like I have given lots of examples in my previous videos, so you can take out examples from there for each point group and check out that are those example polar or non-polar. Okay, and then you will conclude for that only. So this much if you will do, like if you will work for yourself only, like if you will watch videos, previous videos, and if you will like practice this question, what I'm saying, that practice for all the point groups here and check whether they are polar or non-polar, then you will understand more, and maybe you will be able to do the question yourself. Okay, and whenever it will come in the next exam. Okay, so let's move on to the next question, that is the molecule diborane belongs to the symmetry group. So we have the molecule diborane. Okay, so let's first draw the diborane. So the molecule looks like this. This is the structure of diborane. So let's check out, is there any axis? Okay, so the first axis which you will see over here is a C2 axis, which will pass from the like between these two boranes, and when you move the molecule by 180 degree, you will get what? You will get the same molecule. Okay, so that will be a C2 axis passing between these two boranes. Okay, then let's check out, it's a C2 axis, so we have to check out, are there more C2 axis are there? So one C2 axis is possible like this. Okay, if I pass axis like this from here, and if I rotate this molecule, then what will happen? This boron will move here, and this boron will move here, then this hydrogen will come here, this hydrogen will come here, and these two hydrogen will interchange. So one more C2 I have got. Okay, one more C2 axis is like this along this z axis. Okay, so if I rotate molecule like this, what will happen? These two hydrogen will remain at their positions. This boron will come here, this boron will come here, this hydrogen will come here, this hydrogen will come here. Okay, I hope you are getting all these things. So we have three C2 axes, and all the three are perpendicular to each other. So what we get, that we have a C2 and plus two more C2 are there which are perpendicular to that C2. That means we are getting, this is the condition for D. We are getting D as a point group. Okay, so D2, because the principal axis is 2, so we are getting D2. Now D2 is in two options, option 3 and option 4. Now we have to check whether there is a dihedral plane or a horizontal plane. So a horizontal plane will be, if I take axis and a plane is there which is perpendicular to that, then that will be called as a horizontal plane. Okay, so if I take this axis like this, that as the principal axis, this z axis, then is there any plane? Horizontal plane means like this, is there any plane which will cut this? So we will say yes. If this is the axis, means the z axis is the primary axis, so we have a plane which will cut like this, which will pass through these two boranes, and which will reflect these two hydrogens and these two hydrogens too. So that will be a horizontal plane. Again, the axis which was along this x-axis, that we can take one more plane that will be like this. Okay, so that plane will, what that plane will do, that will cut these two hydrogens and reflect these two borons and these four hydrogens. So we have that one more plane perpendicular to that. And the third axis which we took, that was like this. So a plane on the paper, that will be the horizontal plane. So we have horizontal plane also, so we have to give the priority to the horizontal plane. I have told in my previous video. So the point group will become to be D2H. So the correct option for this question will be D2H. So see, this was so simple, you can easily get 4 marks. It was asked in CSIR December 2015. Okay, so like this you can easily, like, see, this was also in CSIR December 2016. 4 marks you would have got like easily. Okay, one more question we will take like this about this point group from CSIR. Okay, so this question came in CSIR December 2017, and the question says that the molecule with the C2 axis of symmetry among the following is. So we have 4 different options, and this question I am not going to solve, I am leaving it for you. You have to draw the structures of these 4 molecules based on the VSEPR theory. If you don't know about that, how to draw structures and how to solve their VSEPR theory, then you can watch this video I have already made for VSEPR theory, and you can watch that video. From after that you will be able to draw the structures of these four molecules. Yeah, and after drawing the structures of these four molecules, what you have to do, you have to find out that whether C2 axis is there or not. Okay, so this question, this was recently asked in December 2017, and I am not solving it. You can comment the answer in below comment box, and I will be telling you, like, if you will not be able to do, I will be like telling you how to do that. Okay, so don't worry about that, and try to solve it so that it will give you confidence. Okay, so try to solve this question and do answer this in comment box. Okay, so next question, which was asked in CSIR June 2015 exam, and this question was based on the multiplication of two symmetry operations. So the question says that the product of C2x and sigma xy. C2x is given that it is a twofold rotation along x axis, and sigma xy is xy mirror plane. So we have to give that what will be the product of these two symmetry operations. So let's check it out. So I have already told you, like, if x, y and z, we have three axes over here, and if we apply C2x, then I have told you, in the case of this C2 rotation along any axis, what you have to do, you have to just like, you don't have to change the direction of, means the sign of that axis, and the remaining two axes will change their sign. Okay, so what will become, it will become x will remain as it is, and minus y and minus z is there. Okay, now you what you have to do, you have to apply sigma sigma xy. Okay, so for sigma xy means a mirror plane along xy axis. So what you have to do, in case of when you apply a mirror plane along any plane, then if you apply along xy direction, then the sign of those two axes will not change, and the third one will change. Okay, that I have already told you in the starting of this video. Okay, so here we are applying xy plane. X and y will not change, z will change, so you will end up getting x minus y and z. So this will be the resultant, okay, of product of these two. Now what you have to do, you have to draw the, like, you have to write the matrix representation of all these four, and you have to check which one will like match with this. Okay, so first we will check about sigma xz. So x, y and z is there. If I apply sigma xz, then what will happen, I have told you, in the case of any mirror plane, if you are applying, then what you have to do, you don't have to change the sign of those axes of the plane. You have to just change the sign of the third one. Okay, means here x and z will not change, y will change, so you will get x minus y and z. So this is quite simple. Okay, you have got this. Yeah, they have matched, means the product of these two will be equal to sigma xz. So this will be the correct answer. So in this way, like in CSIR June 2015, you can easily do this question. Okay, this was asked for I think for 2 marks. Okay, so this was very simple question, and this question is, you can only do this question if you know the matrix representation. One more question we will take based on this matrix representation. Okay, so this was asked in CSIR December 2014, that the product of sigma xy and s4z, and where s4z is a fourfold improper axis of rotation around z axis, and sigma xy is rotation along xy plane. So what will be the answer? There were 4 different options. So see, this question either you can do with the matrix operation, which I have told you. For S4 matrix, you can design that X4 matrix, and from that cos theta sin theta value, and you can do with that multiplication of that matrix. But I am not making this question that difficult, but I will be giving you a very simple thing. Okay, see, this question was very easy. It was for 4 marks, but the question was very simple. See what it has said, that the S4 rotation is along z axis. Okay, so z axis is like this, x axis is like this, and y axis is like this. So this is x, y, and this is z. Okay, so what is happening over here, you are applying a improper axis along z direction, and you are applying a plane along xy. Okay, see, the plane will be the xy plane. The xy plane is this one, and the plane is perpendicular to the axis. Okay, see, sigma xy is perpendicular to z axis. You know this thing. Okay, so since it is perpendicular to this axis, and you know that S4Z can be written as C4Z into sigma xy. Why? Because any improper axis of rotation is product of proper axis of rotation along same axis into a plane which is perpendicular to that axis. So C4Z into sigma xy. So this you can tell from the like you can write S4Z in form of this. Here in this question we are given with sigma xy into S4Z. So if I write all these things, it will become sigma xy into C4Z into sigma xy. See, the product of two planes and the same planes, if you apply a plane, xy plane, it will invert axis, and if you apply same plane again, it will again invert the axis. Means the axis, the all total the axis has remained on its own position. See how? If I apply sigma xy once, then what will happen? It will reflect z direction in negative z direction. Okay. Then again if I apply xy plane, then what will happen? The negative z direction will again reflect to the positive z direction. Means the positive z direction is like it is on its own place if I apply sigma xy two times. Means the product of sigma xy and sigma xy will be identity. Means nothing will happen. So what we are left out is identity when we apply sigma xy two times, and C4Z is there. Product of identity with any operation is that operation itself. So we will get C4Z. So the correct option for this question is C4Z. See, this question can be easily done with that method also, the matrix method, in which you have to construct a matrix, S4 matrix, in which the theta value will be 90°. I have given you the formula for means the matrix, how to draw that, and you can put the value of theta is equals to 90° over there, and then multiply that and check. Okay, so from there also it can be done, but this was the easiest way, so that's why I have given you this way. So till now I have solved few questions which were asked in previous 4-5 years, and I hope that you have understood how to do this type of question. And I know I'm little I'm not that regular with the videos because these days I was busy with my research work, and like it feels very good that you people were waiting for my videos and you were constantly asking me why I'm not posting videos. So that's why I've taken out some time and I'm posting this video, and soon I'll be little free, and then I will be posting videos regularly. These days I'm little busy. Okay, so please you people also like cooperate with me, and you study what I have already taught you, and you practice more questions. Okay, you practice more questions from gate also on this group theory on gate, and all the question, if you practice all the question, all previous questions, then I don't think that you will face more problem in the upcoming exam. Okay, so thank you for watching, and if you have if you are new and if you haven't subscribed the channel, please subscribe it, and please like the video if you like. Okay, and share it with your friends. Thank you for watching. Thank you.